Okay guys, what we're going to do today is I'm going to show you how you find the derivative of the arctangent. So if y equals arctan x, that also is sometimes written as tan inverse x, then first of all what you want to do is get rid of that arctan. So tan both sides, and what will happen is on the right hand side the tan and the arctan undo each other, so you end up with tan y equals x. And this is similar to the last video where we were finding the derivative of sine inverse, or the derivative of arcsine, where this equation here, tan y equals x, is going to be important for us, and we're going to come back to it later. So just keep that in your mind. Tan y equals x. We're going to come back to it at one of the last steps. So what we do here is, what we want to do now is similar again to the last video. We want to differentiate both sides with respect to x, and when we do that, the left hand side is in terms of y, so we have to attach a dy dx whenever we differentiate the left hand side. So the derivative of tan is secant squared, so it's secant squared y, attach a dy dx. And then on the right hand side, the derivative of x with respect to x is 1. So now solving for dy dx, which is what we seek when you solve for dy dx, you're dividing by secant squared y. So after you divide by secant squared y, now, similar to the last video, we're going to use a Pythagorean theorem for trigonometric functions. And that Pythagorean theorem is, this is what we have right now. The Pythagorean theorem that we are going to use is tan squared. The Pythagorean theorem that we're going to use is tan squared theta plus 1 equals secant squared theta. And that comes from your trig identities. The Pythagorean identities, one of the first 3 identities that you get in trigonometry. So since now we can, and theta is a dummy variable, so if I wanted to replace theta with y, I would I would be able to do that with tan squared y plus 1 equals secant squared y. And now I want to plug this in for secant squared. And when I plug in for secant squared, you get 1 over 1 plus tan squared y. I just switched around the terms. 1 plus tan squared y is the same as tan squared y plus 1. So now, back to what we said earlier, where we said we would come back to it. Tan y equals x. So if tan y equals x, then if tan y equals x, then tan squared y equals x squared. So we're going to plug x squared in now for tan squared. And you end up with the final result. Dy dx equals 1 over 1 plus x squared. So that is the derivative if y equals arctan x, then the derivative is 1 over 1 plus x squared. So let me take you through some of our three trigonometric identities. Arctan x, that's the one we just did. If y equals arctan x, the derivative is 1 over 1 plus x squared. We also did if y equals arcsine x in the last video, then the derivative is 1 over the square root of 1 minus x squared. In arc cosine, the derivative of arc cosine is very similar. If we have a composite function, y equals arctangent of u, where u is a function of x, then you just attach a du dx using the chain rule. So you get these three. In the next video, we will do some exercises using derivatives of inverse trigonometric functions.